this recording we'll start talking about electrical circuits. Okay, in here we have in front of us a basic electrical circuit. It's made up of It's made out of a light bulb, a battery, a switch, and wires to make the connections. Okay, this circuit was built with the circuit simulator from fed.colorado.edu. We can build it quickly here. I pick up a light bulb, wire, battery, and a switch. Now here is I'm making my connection. I don't need as many wires, but for looks I'm doing it. Okay, and then I'm going to have another one here and another one here. We have our completed circuit, and then to be able to see the light, we turn on the switch, and we have a running circuit right now. Now, what's important? What do we need to get something to light up? Okay, one typical exercise that we sometimes get to do is to be given just a battery, one piece of wire, and a light bulb, and asked to light up the light bulb. Let's do that with that simulation. Okay, come on here. So I'm going to erase what we have here and do that one. So what I have is one battery, one light bulb, and a single wire. How can I light up the light bulb? Okay. The idea here, for any circuit to work, for any electrical circuit, you need a complete path from the negative lead of the battery all the way through the circuit back to the positive lead of the battery. So I'm going to spin the battery here and directly connect it to the light bulb. Put the light bulb on top of the battery. So now here we have a connection from the positive lead of the battery to the light bulb, and then that's it. So to complete the connection, I'm going to connect the bottom of the battery, the negative lead, to the other end of the light bulb. The light bulb has two ends, one in the bottom, one in the side. So I'm going to connect this to the side. And there you go, you have the light. Okay, of course, all these examples would not work. In this case, we have just one connection from the positive lead of the battery to one end of the light bulb. The light bulb has two ends. One end is the bottom, this one, and one end is on the side. This one is also will not work because the battery is connected to just this end, to the socket end of the light bulb. This is our working model. Okay, again, a big picture of it. So we have a full closed circuit from the positive lead of the battery through the light bulb back to the negative lead of the battery. Now, so what we had to do in that circuit, for the circuit to work, we had to have an electrical current. So let's define what we call electrical current. An electrical current is simply the flow of charge, electrical charges. Normally, in an electrical circuit, the charges are going to be electrons. So it's going to be the flow of electrons. Now, the way we measure current is how many coulombs per second. How many coulombs per second, we call it amperes. or in short we call it amps. Now, remember, electrons have a charge of minus 1.6 10 to the minus 19 coulombs. So a 1 coulomb, so you divide by 1 coulomb by that much, you find how many electrons make up a 1 coulomb. So 1 amp, remember what 1 amp is? It is 1 coulomb per second. So 1 amp is 6 10 to the 18 electrons per second. That's a huge number of electrons per second. Now, excuse me, one important note. People have discovered electricity before discovering electrons. So because of that, they didn't know what's the cause of electrical current. And they chose a direction for electrical current. As it happens, the direction they chose would have corresponded to a positive charge flow, not a negative charge flow. Now, mathematically, it does not make a difference. A positive charge moving this way is equivalent to a negative charge moving this way. Mathematically, it's the same thing. So because of that, even after we discovered that the cause of most currents in most cases is negative electrons, we still refer to the current as if it were the motion of positive charges. So in other words, when we see electrons in a wire moving this way, the current is actually moving in the opposite direction. Okay. Now, not all people adopt this convention. Some people in some military schools don't adopt it. Another note that's really important, it is not true that only electrons can move. For the ones among you who did a little bit of chemistry, you know that ions, you can have positive ions in a solution moving. So then you have a positive charge that is moving, a current made up of positive charges. In some cases, you have both positive and negative charges moving at the same time, adding up to the current. But in most electrical circuits, what's responsible for electrical flow is electrons. Let's go back to the simulation here. I'm going to delete this one here and try to build up a quick and simple one. Okay, I'm going to put the battery here. Come on. I'm going to have a switch because it helps to control things. And here's my completed circuit. I close. Now, note, so this is my positive lead. And you see the electrons are moving in the opposite direction. They are moving into the battery and out of the battery. Now, again, what we define current is charge over time, coulomb per second.